We're fortunate today to have Martín Hernández Navarro as a speaker. Martin has a dual degree in mathematics and physics from Complutense University of Madrid, which I learned from Wikipedia is one of the oldest universities in the world. His firm, Tidy Systems, provides business consulting, specializing in product development, software engineering, and technology strategy. Tidy develops technology prototypes and software solutions using data science, big data, and artificial intelligence. Prior to founding Tidy, he has worked at Accenture and UBS Zurich. Please use the chat for questions during the talk. We'll also have a dedicated Q&A session at the end. Martin?
Thank you, Sean. Thank you for hosting me today. Thank you, Patrick, also for the opportunity to be presenting today. I hope the audience likes it. Today we will talk about big data, data science, and artificial intelligence with a focus on the role in organizations. In this cover, we will try to cover these 4 topics. First of all, we need to understand what exactly is big data, data science, and AI, and when to use them, and also when not to use them. Then we will navigate 2 examples of projects that I have worked in the past. So I hope these 2 projects can help illustrate the usage of the technologies. Then we will move on to the business value that is created by each of these 3 disciplines. And then we will conclude with a practical framework to choose the simplest stack that helps frame decision or effective action so that everybody has a bit of a real understanding of the business impact. So let's get started. We'll start with the big data conception. So basically, big data is a technology for distributed data processing across a cluster of machines, right? It is primarily used when the data that we have to analyze, that we have to do some tasks, some joins, aggregations, the data is super large so that it does not fit in the RAM of a single machine. So that we have to spread it across the cluster of machines. It actually solves the high performance computation problems over large data sets. Also, it makes the memory scalable across multiple machines. And it allows for reliable processing despite failures in certain machines, which are called the nodes, the nodes of the big data cluster. So it's more an architectural question, and it's all about making large-scale data processing possible. Now, if we move on to data science, it's basically about understanding data, but it has nothing to do with automation, at least directly. Data science basically turns data into insight to support human decisions. So it's about analyzing the data, extracting patterns, or something. Oh, sorry, if maybe everybody could get muted.
Sir, can I have a...
Okay, thank you. So it's basically about turning data into insights to support some human decision that comes afterwards. The foundations are, of course, statistics, modeling, and analysis. It combines these techniques and also focuses on some specific business questions. So it has to answer one question that is defined before the model is built. It requires for sure enough data for statistical relevance. If we don't have enough data, then probably we're not solving any problem in an efficient way. And it produces insights, forecasts, and explanations. But it's essentially something that turns data into insights to support human decisions. It does not automate decisions. It does not replace human judgment, and for sure it doesn't require massive infrastructure per se. It amplifies human reasoning with data. Now let's talk a little bit about artificial intelligence. It starts where the rules end. So basically, artificial intelligence enables systems to act autonomously based on what they have learned from examples. Instead of defining explicit rules, we teach the system some examples and of situations, and from these examples, what the outcome should be, right? So then it allows the system to learn patterns directly from data and eventually to generalize to new situations. As key characteristics, the rules, as I said, are not manually encoded because we directly give the examples, not the logic, and the system behavior improves with experience. So what does this exactly mean? So the more examples that we have taught the system, the better it should behave in principle. Of course, this leads to some error generation because as there is no clear rule, there's always some probability for an error. And then the model performance will improve as the system learns from the errors that it has been encountering. That's also why feedback to the model is crucial. In general, AI is used when decisions can no longer rely on human intervention and then must be executed automatically, right? It only makes sense when the cost of the error generated is either controlled or well managed. And that's always a business decision at the end.
Martin, we had a question in chat on could you explain one more time the difference between data science and AI?
So basically, the question was, what are the differences between data science and artificial intelligence, right? So data science, at the end, it does not try to automate the decision. It just extracts insights from data to present some information to the human so that at the end, the human can take better informed decisions. That's the goal. I mean, we will see it maybe more clearly as the presentation continues, right? But then artificial intelligence, on the other hand, tries to learn from examples so that the system internally can understand how to behave whenever the next example of a new situation is encountered, right? So this is how it generalizes to new situations. Also, for sure, this means that the artificial intelligence systems do not have explicit rules, whereas the data system ones typically have. I don't know if this answers the question. Yeah, sure. So basically, this project example is about a retail company that has 250 stores, right? And they have two different tasks together, right? First of all, they want that within each product family, they want to identify the lowest rotation SKUs that they have in each store and also recommend them for removal from store inventory. So what exactly is an SKU so that everybody understands? Is each product along with the entire set of features that the product could have. So for instance, Coca-Cola could have, many different bottle sizes. So Coca-Cola of 2 liters is one SKU, Coca-Cola of 1.5 liters, another SKU. So that is the concept. And also they want to detect which SKUs within each family are not being sold at all at the store level so that they can focus on the most profitable or mostly sold ones, right? So for this, we built the following tool that was a dashboard using group-wide purchase data that was broken down by product, store, and rate. And then we could highlight the relevant SKUs, the ones that were recommended for removal, right? So in this context, of course, we have a strong seasonality, right? Because, for instance, during summertime, cold beverages are sold more than during wintertime. And also during Christmas, seasonal products dominate sales. So this means that we have to observe that seasonality. And this is how data science helps. It helps us analyze the seasonality patterns of all SKUs at every store level and identify also the best SKUs to remove from each product family and store based on the business-driven metrics. In other words, the customer or the client gave us some business metrics that they wanted us to observe in the dashboard, and for sure this week we could implement directly in the technology along with the seasonality patterns. Or for sure, 250 stores are too many stores together, right? So then this project was split into 2 different phases. First of all, we had the pilot phase with only 15 stores, and then the rollout to the rest of the stores. So in the pilot phase, the good part is the models are defined and the business value proposition is delivered across these 15 stores. We focus on these 15 stores, then we define the models, and then the value proposition is delivered. Data fits in memory on a single machine. This is also good news because the architecture is simpler, and the dashboard front end is built, right? So then the product is delivered, at least for the pilot phase. Then models are implemented, assuming a single machine architecture, and Python Scholar is chosen as the data science library. And SQL database is chosen also as the data source, right? Now, when we move on to the rollout to all stores, this is the 250, the good part is that the models remain unchanged. However, now data no longer fits in memory on one single machine. This means that we have to migrate to big data infrastructure instead of a single machine infrastructure. Specifically in this project, we had 15 worker nodes plus 1 master node, right? And then the dashboard front-end functionality remains unchanged. This is also good because the value proposition was not only delivered but also somehow presented using this dashboard. And it only requires minor adjustments. Then the models are migrated to a big data library, which in this case is Python PySpark instead of Python Scholar. And the SQL database is still chosen as the system of record with only one distinction. Now we have a data extraction and aggregation pipeline that materializes the data into some Parquet files. These are columnar files that are suitable for large-scale analytical processing, right? So yeah, I mean, let's continue with the other project. That was digitization of paper receipts at retail companies, right? So at retail companies that for sure do not have at the moment some native digital receipt generation capability. So what exactly was the technology? When the paper receipt was printed, I mean, a picture of the receipt was taken and then the data was extracted and then structured in the system, right? So that eventually that could be digitized. At the beginning, we had two different approaches that we considered. First of all was to use an OCR algorithm, optical character recognition algorithm, to retrieve the words, and then an NLP model to understand what exactly every word meant. The upside was that under enough picture variability, the models will generalize well to unseen receipts. But for sure, the downside is that the variability of the pictures is immense. And this means that we need lots of fine-tuning even for quick demos. For sure, if then, I mean, some specific character appears blurred or there are some words in the background of the receipt, when the user takes the picture, then we cannot match that so easily. And the second approach was to use a third-party OCR service already built that returns the extracted words and fields with some X and Y coordinates, right? And then we can create a model to make sense of all that information returned, along with some rule-based logic. The upside is that the coordinates-based models are usually easy to build for every company, but the downside is that it doesn't generalize well to receipts of other companies due to different coordinates of the data. In other words, the data will appear in different places in each, I mean, for the receipts of each company. And then you have, of course, uncontrolled cost if users start taking lots of pictures, right? So the business decision was to go ahead with a second option, just to quickly test the service acceptance in the market, right? And then we developed that, and the result was that the initial adoption was good. But then we saw that in the workflow was the following. First of all, the picture had to be taken, and then the email address of the client had to be filled in. So this workflow was taking too long, especially for the customer, but also for the employee. We were consuming lots of their time. So instead, I mean, we saw it there, the workflow gets impacted by the order of the steps to receive the digital receipt, not by the model itself. So the model didn't have a direct impact in the workflow. So then we decided to make another iteration over the workflow. We inverted the order of the steps, and instead we asked the customer to fill in their email address first, as the employee was serving the customer, and then the paper receipt gets printed, and then the picture was taken. For sure, then the digital receipt is sent automatically to the client. And we saw that the service adoption doubled, right? So why are we saying this? As key takeaways in the pilot phase and then the go-to-market, we have to always pick the simpler workflow to test if the market wants the service that we are offering or they don't. And for this, we should go ahead with the simplest model that we can choose. When we make further product iterations, again, it's the workflow that drives the success and not the model itself. So we should try to optimize the workflow as much as we can while we keep the model as is for as long. At the end, we're just focusing on the business value generation and increasing customer satisfaction. At the end of the day, users will just want a service that works. If you harness data science techniques, deep learning, it's your business, not theirs. Explainable, repeatable results is exactly what customers are looking for, right? Now, let's move on to the technologies that create business value. Sorry, data technologies. I mean, as a rule of thumb, the value only emerges from the data technologies when the decisions or actions change, not when the new system reduces the error rate of the previous system. But the data technologies by themselves do not create value automatically. Also, this is very important. If nothing changes after the system is implemented, then there is no intrinsic value. I mean, there's no value that was being delivered by this new system. In general, there are only three ways that data creates business value. Either improving some human decision, that will be data science, either automating some decision, that will be artificial intelligence, or scaling something that already works, and that is big data. If a use case does not clearly fit one of these three cases, it creates cost, not value. So let's explain the three of them now in more detail. So data science. Data science in general is used to make better informed decisions, like for instance, higher revenue margin, or decisions with less uncertainty. That decision must be taken, of course, with some high frequency. If the decision is only executed once a year, probably you might find some other cheaper process. And at the same time, the economic impact of the decision must be measurable, right? At the end, if the decision remains the same, then the model does not matter. Which model we have chosen does not really matter. Then operational AI, economically, it has a very huge value, which is cost reduction and operational efficiency. From a technical point of view, the speed and scalability now can go beyond human capacity for sure. And there must be some repetitive and frequent decision as well. And then for sure, some action rule must follow. So when the system produces this decision, it has to be delivered. Then the error cost, as we said earlier, must be acceptable or at least controlled. In general, if a human must always validate the output of the AI model, then this is not really an automation. In AI, humans are moved from execution to supervision, constraints, definitions, and objectives. Last but not least, big data. In general, big data just scales something that already works. It's more of an architectural question. It adds operational efficiency and stability. It also requires some process that creates value, as we said. And there has to be behind some factor that creates a technical scalability limitation. It could be data volume, memory, or end-to-end processing time at scale. But in general, big data does not create new value, it serves existing value at scale. A data initiative in general creates value only if, the three of them, if there's a clear decision or operational process, there must be some business owner who is accountable for acting on the output, cannot just float around. Some measurable economic metric must be defined. That is the goal of the system. And the output will be embedded in some daily operations workflow so that it doesn't float around again. The value has to be also recurring, not one-off. Okay? Also, as a rule of thumb, if some working system disappear tomorrow, then something measurable should break. This is also one of the measures that tell us that, yes, some economic metric was being driven by this technology. I mean, just as quick examples, recommendations leading to higher average basket size, or demand forecasting that leads to adjust purchasing at retail companies, and then these gets translated into fewer stockouts and thus higher sales. Just a quick checklist to validate the business value proposition. We have the following questions. What decision or process does the system improve or automate? How often is this decision taken as well? Who will be accountable for acting on the output? How is the economic impact measured? And if the system were in use today and then suddenly disappear tomorrow, what exactly could break? If these questions cannot be answered, then probably there is no business value behind. Just some actionable.
We've got a lot of questions, Martin. I think let's take those. So working backwards, you talked about in the second example, the system is taking a picture of a receipt. The question is, why is that? And was there that means that there was an integration with the POS terminals?
That's right. That's right. At that stage, there wasn't any integration. Yeah.
So at a higher level, what are the risks that companies should consider when using AI as applied to data processing?
So, I mean, one very important danger is the error cost, right? So the errors that get generated directly by the AI system has to be measured. That has to be measured. What is the likelihood, or in general, how many times it happens, and what is the impact? Because sometimes it happens that, okay, you have 95% accuracy of the model, but then in the rest of this 5%, maybe the impact is huge. If it is in financial sector, then probably you're doing some wrong recommendation that leads to losses. So it definitely depends on the impact of the error as well. That has to be measured. And then usually this only happens when there is some team that is accountable for that as well. Yeah. I mean, this is for sure very important. And then the other big danger usually is data quality. So for sure, all these data technologies are heavily dependent on the data quality, right? At the end of the day, data is the oil that gets consumed in these systems, right? So if the oil has a low quality, then the output will get low quality. Usually there is a saying that says garbage in, garbage out, right? If you are sending garbage to the model, then you will receive more garbage, which is actually expensive garbage. Yeah.
Okay. You want to share your summary slide? Sorry.
Sure. I actually had this actionable framework to share
Okay.
today, but
Okay,
I
we'll
think
go
with
through it. Let's go through this then. I'm sorry.
no, but actually think I don't know if you are running late because we have
No, we're
this.
good. We're gonna with even with all of the hoo-ha, we're
Oh,
okay.
okay,
But I
okay,
think once we
perfect.
open it for questions, you're going to get a lot more questions.
Yeah, that's great. That's great. I mean, important to note, there is no best data or AI stack in general, right? It will heavily depend on the context that we have, the constraints, and the risk at the end of the day. And I mean, the following framework, we will just try to help you choose the simplest setup that creates value directly. For sure, if in some question you hesitate between two different options, you should always choose the simpler one that works today, right? I mean, the questions are the following. I don't know, Sean, if you still think we can go in detail, or otherwise I can just share
So
them in the
I think
deck and then
I think the questions have more been around.
yeah,
So at a high level, these are questions that um would drive the selection, right?
exactly. Yes. So the first question is, does the data fit in memory on a single machine now or in the near future? How fast does this decision need to happen to create value at the end of the day? Could be seconds to minutes or even milliseconds. Is the goal to support a human decision or to automate it? Are the inputs mostly structured or unstructured? What level of model complexity is needed? And who exactly will operate and maintain the system over time? So the accountable team. Um,
So in
I
your
mean,
formulation, the
yeah,
demarc between data fits in one machine and data has to be spread across many machines is the difference between data analytics and or data science and big data.
sorry, can you repeat the question? Demo
The demarc, the dividing line, the
between
boundary
the single
between big
machine.
data, right? So if the data can fit in a single machine,
Yeah,
then in your
yeah.
formulation, you're doing data science or data analytics.
Well, in my formulation, the single machine, I mean, it is only an architectural question, right? The question is if the data in the near future will not fit in one single machine, then you should try to, foresee that you will require some big data technologies in the future. But
Right.
regardless of the
So
usage, right?
if you
If
break the boundary of one machine, you have to move to
yeah,
big data structure to manage it.
yes, exactly.
Okay.
But it doesn't matter if it is for a data science model, if it is for an AI model, whatever.
Okay. So
Yeah,
we had a comment around modeling the AI errors that in banks they call the impact of model error model risk. And then the financial institutions have a very robust framework for identifying, categorizing, and classifying those risks. So
yeah,
different professions have nailed this down better.
yeah, definitely. Um, So I think then, I mean, if we have lots of questions in the chat, then probably, I mean, when the deck gets distributed, then, I mean, the person that is interested can also manage, I mean, can go through these answers. So we can just move to the summary.
Yes.
So data science and AI build models, whereas big data provides a scalable data architecture. Data science helps humans make better informed decisions. And artificial intelligence automates decisions, but at the end of the day, errors are inevitable and must be managed. Big data should only be used once value is proven and needs to scale. So if we can delay it until the scale is required, even better. And market needs are the system's drivers, not the models, right? We should always start with the simplest model and architecture possible, and always improve the system technically only as the business needs demand it, not earlier than that. Right. Thank you very much for your time. I think that was it from today. I'm happy to take any more questions that are on the chat, or if somebody wants to
Okay, we'll open it
speak
up for
directly.
questions now.
Sure.
So you've talked about the memory in one machine and the processing in one machine. Are the newer GPU-based architectures having an impact on these calculations? Do you see that as having an impact on any of this framework?
I mean, when it comes to the GPUs, the question is that GPUs are usually slower than CPUs, right? So when you have a constraint in the execution time, then most likely CPUs are required, right? So then you still need to go ahead with the same, I mean, with the RAM requirements or the RAM constraints of the single machine, and then try to see if it fits in one machine, and otherwise you have to migrate for sure. So I mean, it's in most cases it doesn't play any role.
Okay. So we have a question on any experience or perspective about the manufacturing industry, in particular, collecting data from manufacturing machines using an AI agent or other ways.
Unfortunately, I don't have any experience in the manufacturing industry so far. I mean, maybe what I can share is that I mean, I know in some industries, where the production is very, very tight and the execution time of the machine for sure is super, super fast. You sometimes need to have some streaming architecture within big data when you produce lots of IoT signals. But honestly, I'm not an expert in the manufacturing industry, unfortunately.
So that gets more into real-time process control, depending upon
Exactly.
what they're trying to do.
Exactly. Exactly. Because, I mean, typically many big data processes are run in batch, right? So typically also the Spark technology, but for sure you cannot wait for a batch if you are running lots of machines in some industry. So yeah, you need the near real-time process.
Yeah.
So we had another question on the store example. And
Yeah.
the question is, the customer's inputting an email address on each sale. Did you build
Mhm.
a look-aside email database to reconcile different customers shopping at different locations?
This could potentially be have done, but then for sure the company needs to have the email address already registered and somehow linked to the sale, at least with a timestamp, at the very minimum, right? And this didn't happen. So we needed to retrieve the email address by ourselves. That was the thing. For sure,
Okay.
then things would have been easier. Yeah.
Okay.
Any more questions, maybe?
So can we go back to your summary slide?
Sure.
So what do you see as the key problems driving the adoption of these AI systems today?
Within teams, you mean like in companies?
In companies, in the kind of project you're seeing, what are the application areas that are driving this as a
uh
technology choice?
Application areas, retail industry is applying a lot. They are trying to, even for demand forecasting, when it comes to promotions being applied to the right client, try to have some promotions also for the upsell, or trying to make the customer come back again as soon as possible. So there's actually a lot. And typically as well, data science and AI models are combined together. So there's typically there's no only one model being applied, right? So there's a combination of that. So complex systems usually happen in retail companies for sure. Then I know also in the medical industry, in health, there's lots of deep learning research as well going on when it comes to image pattern recognition, like for instance, to detect if a patient has something very simple as an elbow inflammation, or maybe also cancer, right? So then there's definitely lots of traction in these spaces for sure.
Interesting.
Hmm.
And how often do you see these projects started out of a desire to do something, as opposed to you stress that the market needs must drive the
Yeah.
system. How often do you see that this is a kind of a new chocolatey goodness and that's driving the choice to go do this?
Yeah, actually, many people now have this question, right? They have heard that AI is super popular. They say, well, I want to implement AI, I want to do something. And then for sure, the first question is what exactly you want to achieve with that, right? I mean, what is the goal? I mean, are you trying to generate higher revenues? Are you trying to increase your margin, reduce costs? So for sure, many people do not have a clear, let's say, business metric of how exactly it can affect the system. So, I mean, the system can affect their business. They don't know exactly what they want to achieve, first of all. And then for sure, data quality is usually not that good in small businesses, right? Because they have lots of manual processes. Their IT systems are not that well developed, so that the traceability of the data is not that good. So definitely these are, I mean, some challenges now, right? Nowadays, yeah, for
So,
sure.
do these AI systems present any kind of particular security risks or unique security risks? There's obviously all kinds of movies and popular movies about AI doing different things, but in your practical experience, are there unique risks that the AI systems present that you need to design for or anticipate?
I mean, for sure. I mean, as I already said, AI systems will always generate errors, and this is inevitable. So the question is always, what happens when the error happens, right? I mean, when the AI system generates some error, what exactly is that error, and how are we going to proceed, right? I mean, what exactly are we going to do with that error? This still happens lots of times because people do not truly understand that. I mean, many business owners, even in SMEs or even in medium companies as well, right? What they understand is that IT systems are usually deterministic systems. And whenever A happens, then B follows, right? And this does not always happen in the AI system. So this is actually something very unique as a risk in the market, right? And and yeah, I mean, sometimes you try to see if you can recommend something that they could do in case that ever happened. But yeah, definitely sometimes there are things that you cannot foresee. And this happens, of course, in the more or most complex models. If it is, let's say, an image pattern recognition classification, the typical example of a cat or a dog picture, then probably the impact is not that big, but otherwise it gets tricky for sure.
So looking at two sides of the coin, the data models are
Mhm.
deterministic. Given the same inputs, they give the same outputs. The AI models are stochastic and may give different answers even with the same input.
Uh, I mean, not necessarily. Data science models are typically also statistical models, right? So
But
at the end of the
but will the
day,
model give a different answer with the same input?
I mean, in principle, no, because I mean, if the output of the model is different weights, for example, for the likelihood of different scenarios, right?
Right.
Then it should be the same. But at the end of the day, many data science pipelines nowadays also harness some AI models, right? You sometimes also see some neural network that is embedded within a data science model. So in these situations, it's not that straightforward. Yeah,
Right, but that would be where they blended two different kinds of models, right?
yeah, yeah, yeah.
Interesting.
I don't know if we have more questions in the chat.
So Mark Prince put a link to the incident database for AI. So I guess there is a whole now separate category
Yeah.
of problems for AI. Mark, you want to elaborate on that at all?
Yeah, this is kind of the LLM specific type of issue that because it can create information, um, you don't always know if it's true or not or if it's fake. So there's some lawsuits that happened in Canada because Air Canada had a chatbot LLM that promised them like free flights or something. Um, and they got into a whole lawsuit, and it was discovered that Air Canada did have to honor what the chatbot told the clients, even if there was a little caveat in there.
Yeah.
And there's other consulting agencies. I'm trying to find one in Australia. I forget if it was Deloitte or someone. Uh, their report was fake. Um, yeah, hold on. Let me send this to you guys.
I do know that lawyers have been sanctioned for submitting briefs that have citations that were actually hallucinated.
Yeah, yeah,
They're
exactly.
citing a statute or a judgment, and when you that doesn't exist. So they've definitely been
Mm.
sanctions given out for that too.
Yeah, so this yeah, I'd say it's very interesting. And I wanted to ask Martin, like, uh, is any of this kind of specific to LLMs, like the large language models and things like that? Do you have any kind of guidance when it
Yeah.
comes to that world and agents?
Yeah, sure, sure. And this actually brings me back to one of Sean's questions. So basically, something also very unique of AI models is the explainability, right? This is an open problem still nowadays. The explainability of the model basically stands for we need to understand the reasons why the model produced that outcome. And in general, in AI models, this is very easy in very simple models, like for instance, decision trees. But it is not that easy in more complex models like deep learning models, and LLMs are one of the deep learning models that are super popular nowadays. But for sure, it is not easy to explain why exactly the model produced that, right? Because there are different statistical measures that have an impact on the output. So this actually this is a very good example, Mark. Thanks for sharing. I was not aware of that. But for sure, LLMs, I mean, this happens usually when the team understands that LLMs are bulletproof, right? And they do not hallucinate, but eventually they do, right? And this is one of the errors that I was talking about. These are inevitable. And for sure, I mean, as it says here, they must be managed. I don't know if you can see my pointer, but they must be managed. And eventually, if you just give the output directly to the customer, you're not managing it. You're exposing the error. You're exposing it. So for sure, this is still an open problem.
So, as I understand it, hallucinations are intrinsic to LLMs, and to manage those errors, you've got to use other techniques that are
Mhm.
deterministic between that output and either the business or the business's customers. Is that
Yes, that's right. But again, then the question is if you are going to give this feedback to the model so that you pretend that it doesn't happen again, then the question is how many hallucinations you have to, what was the name? Data augmentation. So you have to augment the data, right? I mean, you have to give other hallucinations and say, this is not what you should do. Instead, this should be the right answer, right? So then the question is, how you can do that and we still see nowadays that ChatGPT still has hallucinations, Grok, and Gemini, right? The most popular one, so it gets tricky.
it's intrinsic to the LLM algorithm to hallucinate.
I mean, all of them actually have the errors, but I think their
Yeah.
hallucinations are like that, yeah. I mean, intrinsic.
I mean, it's an irreducible aspect of the algorithm.
Yeah.
I don't know if
It's
it
not
is.
a it's not a bug in the algorithm when the
No, no, no,
LLM
no,
hallucinates.
no, 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 no,
Yeah.
no, 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 no. It is not a bug. Yeah, yeah. In that sense, it is intrinsic. In
Right,
that
right,
sense,
right.
it is.
In other words, with a deterministic algorithm, if there's a problem, you fix the algorithm and the error goes
Ah,
away.
for sure, for
Yeah,
sure, for
with
sure, for
LLMs,
sure, for
what's
sure.
called hallucination is how the algorithm operates.
Exactly. Because at the end of the day, it is based on the probability of the next word, right? I mean, what is the most likely word that should come next? And yeah, yeah, that is really unavoidable.
Well, any final questions for Martin before we break? I want to thank everybody. I apologize for the problems we've had. We've actually
Yeah, no
adjusted
problem.
the settings on the Patka account to prevent that in the future.
Yeah, these things happen. I mean, eventually, is that I mean, we have responded quickly. So thank you very much also for your patience, Sean.
Yeah. Well, at this time, I want to thank you for joining us. I'll put a little bit about Patka in the chat if you'd like to.
Sure, sure. And I just wanted to add, if you have any further questions, I mean, now or in an hour, tomorrow, please, you have here my contact details. Feel free to keep in touch for sure. Thank you very much.
I keep trying to cut and paste that, but if you want to put your contact information in the chat, we'll make a copy of the slides available that include the details of his checklist for system implementation, and we'll make a cleaned up version of the recording available.
Yeah.
There we are. Perfect.
Thank you very much.
All right. Perfect. Thanks, everyone.
Thank you.
Bye.
Bye.